Alright, so this is a slight variation of what we had before. The variation is introduced by this 10 here. The famous one was tangent square plus 1, which would turn out to be secant square, but you add some stuff there and then it becomes kind of a nuance that we have to contend with. And here's how you do it. What you could say, hey, wouldn't it be nice if this was x, if this was equal to, if x squared plus 10 was equal to a tangent square theta plus 1. Well, it'll never be that, because it would be much easier to make it match the 10 here and put a 10 there. That would be easier to do. You can't mess around with the 10, you can only mess around with the x. The x is going to be your substitution. And so leave the 10 there, but make the coefficient on the tangent match so that you have 10 factorable and then you get a 1 there, and that would be the way to get rid of that 10. So that's what you want. You want this, okay, so that you can get to this piece. If that's what you want, then you want x squared to be equal to 10 times tangent square theta. If that's what you want, then really what you want is you want the square root of 10 tangent theta to be theta. X to be square root of 10 times tangent theta. That one right there will make that happen, which will turn this into ultimately a monomial. See that? So these numbers here, sometimes don't let that bother you. We did an example like that before. Here's another one where you figured it out that way. This becomes, by the way, I'm going to need this part of the dictionary, so I might as well finish it. Square root of 10 is equal to tangent theta. Just in case I need it, x over 10, square root of 10, is equal to theta is equal to arc tangent of x over square root of 10, just in case I need it later. This is still all part of my nice little dictionary. Sometimes I also need a triangle. We'll see in a second. So this becomes, using my excellent dictionary, this becomes integral of 1 over x squared, which we agreed was equal to 10 tangent square theta plus 10, and then the differential. Oh, I didn't finish the differential. I'll go from here to the differential. Differential of x is equal to square root of 10 times a secant square theta d theta. So this would be square root of 10 times a secant square theta d theta. This of course becomes the square root of 10 outside. I could pull out this 10 as well outside. Pull that one out and pull this one out, leaving you with secant square theta all over tangent square theta plus 1, differential of theta. The bottom of course is famously known to be secant square theta. So I can exchange that for secant square and ultimately cancel it with that, leaving you with square root of 10 over 10 times d theta, which of course becomes the square root of 10 over 10 times theta, which of course we agreed was equal to square root of 10 over 10 arc tangent, back to my dictionary, x over the square root of 10 plus c. That's how you deal with these constants here. You don't change them. You try to make the coefficient in front of the trig function match it. Okay, so you guys see you next time.